Let's now see how to create this booking. If you remember from our diagram, we have performed these steps so far. So we performed step 1, we performed step 2. The next thing is to perform step 3. Now I'll show you how to use Kafka to perform this part of our service. To implement the synchronous call between booking service and order service, we will be using Apache Kafka. So Apache Kafka is an open source distributed event streaming service that is used to handle real-time data feeds. It is designed for high throughput, fault-tolerant, and scalable data processing. It is widely used in the industry, so let me show you how to use it. It has some main components, which are the producers that send the messages. In our case, booking service will be producing the message. We'll have a broker, which is the actual Kafka server that stores and distributes the messages. And then we've got the consumer, which in this case is going to be reading messages from these topics. In our example, our consumer is going to be order service. What we need is to be able to run Kafka on our local machine. In order to do that, we need to actually go to our inventory service. And in our inventory service, we want to open our Docker Compose file and add few more services. So apart from MySQL, we need to add Zookeeper. So Zookeeper is used to manage Kafka brokers. It manages the topic partitions and it chooses who the leader is. So because Kafka is distributed, we might have multiple brokers and brokers might fail, new brokers might be created. All of this is managed by Zookeeper. It is slowly getting deprecated in favor of Craft, but I still want to show you Zookeeper because it's still widely used. Just add these bits here. Next thing we need is a Kafka broker. So this is the actual broker that is going to be listening on port 9092 from the outside. This is the internal mapping. In this case, this is a unique ID you want to assign to our broker. It's useful when you have multiple distributed brokers. In our case, we're just going to have one. We want to define Zookeeper, and in our case, we have defined Zookeeper up here, and it's running on port 2181. And this is not distributed really, so we're just going to have one as a topic replication factor. The next thing we're going to be using is also Kafka UI. So basically we want to be able to see what's going on. It's going to be quite useful in understanding the whole flow of the events and the messages. So you'll need to add this service. And the last one is Kafka Schema Registry. I'll explain this a bit better when we're actually doing the testing, but in simple words, this Kafka Schema Registry basically verifies that the JSON that you are passing to the broker is actually valid. Go ahead and copy these ones. This is actually Kafka broker, so make sure the names are correct. And another thing, notice the ports. So Kafka Schema Registry will be running on port 8083. Kafka UI on port 8084. This is because we already have inventory service on port 8080, booking service on port 8081, and then we'll be having order service on port 8082. So the next one in lines are 8083 and 8084. So now that we got this, let's restart our Docker container. So let me do Docker Compose down. Let's stop whatever it's running at the moment. So I had them already running, but just to show you, let's run the Docker Compose file again. Up -d. These are started. So we've got all the services running for this part. We can now go to the booking service. So if you open the booking service app and go inside the booking service class, we are now ready to create a booking. So this booking is going to be an event that is going to be put on a Kafka topic. We want to create a new package called event. In here, we're going to create a new class called booking event. And this booking event, we're going to add few tags. some constructors and also a builder. We want to add all the information order service is going to need to place an actual booking. Let's have a quick look at our schema. So for the order table, we need a total, quantity, and the customer ID with the event ID. So in our booking event, we want a user ID, event ID, ticket count, and we want the total price. Let's go back to our booking service. We can now create a booking event here. So if we do booking event, and let's use a private method, I think it's going to look way cleaner. So create booking event, and we're going to pass the request, the customer, and the inventory response. So let's create this private method down here. This is going to return a booking event. We're going to pass the booking request, customer, and inventory response. And then we're going to build a booking event object. We want to get the user ID from the customer, the event ID from the request. Let's get the number of tickets from the request as well. And we want to calculate the total price. So the error is because we cannot apply the multiply operation to big decimals. So we need to use the actual method called multiply. Let's do this. Let's do multiply by the ticket count. So we'll get the total price, and this is a long, so let's transform it into a big decimal. So our booking event is now ready. So if you go back up in the create booking method, we have a booking event. So we want to send this booking event to order service on a Kafka topic. This is where Kafka is going to be used. So you will need some dependencies, which we should already have because in the Spring Initializer project, we already included Apache Kafka for Spring. We already have the dependencies. You shouldn't need to add anything else. If you go to booking service, now we want to create a Kafka template. This is what will be used to be sending our messages on Kafka topics. So let's import and let's look at how we created it. So to a Kafka template, we want to be passing a key, which will be a string. And we want to be passing our event. In this case, it's going to be our booking event. And then you want to give it a name. Let's auto-wire it. And we're now ready to use it. So we want to use it by simply calling Kafka template.send. And here you want to give the name of a topic. In our case, we'll be calling it booking. So our topic will be called booking, and on booking we'll be sending a message called booking event. And now let's add some logging. So let's use proper logging using SL4J. So if you go up here, let's add a tag SLF4J, and this is going to help us with logging. So log.info, and let's also change this one, log.info. It looks a bit nicer and it's more flexible for logging. It's actually made for that purpose. We put an event on a topic in Kafka, and we can simply return a booking response. So we want to create a booking response object where we now fill all these parameters. So if we go back here into booking response, just make sure that these are properly defined. Booking ID is going to be a long, user ID. We've got an event ID, so we actually don't need a booking ID because we don't know what the booking is. That will be defined by order service. So let's remove this. We'll be sending back a user ID, an event ID, a ticket count, and the ticket price, which should be a big decimal, not a string. So please change that. So now if we go back to booking service, we simply take each of these parameters from the booking event and we set it as a response. So total price, there is an error. Okay, so this should be called total price, not ticket price. The error is gone. We are almost ready to test this. We need few more things in the application.properties to be able to run this. So if you open application.properties, we need to add some configurations for Kafka. So the first one is we need to let Spring Boot know where this broker is running, and we are running this on port 9092. If you go to inventory service into Docker Compose, you can see here that our broker is exposed on port 9092. The next thing we need to define is the name of the topic. On our booking service, we've decided that the topic will be called booking. You can give it any name you want, but just make sure you then define the default topic in application.properties. And you want to define a serializer for the key, and in this case it's a string. We want to define a serializer for our value. In this case our value is a booking event, and we want it to be serialized as a JSON. So we are now ready to run this. Let's start up inventory service. Make sure that your Docker Compose has run successfully as well. I've started the inventory service successfully. Let's start up our booking service. Let's go to Postman and let's send a request to our booking endpoint. So let's click send. We can see that we get back all the parameters. Now, instead of nulls, we actually get values. If we look into our booking service logs, we can see here the log says booking sent to Kafka. And if we go up here, we can also see all the logs generated by the producer configuration for our Kafka broker. How do we know that this is actually gone onto a topic? This is where our Kafka UI will come handy. So you want to go to localhost 8084. Here we want to create a cluster. Let's give it a name. Let's call it localhost. And the host is actually called Kafka broker, and it's running on port. We can find the port in the Docker Compose 2092. Make sure to use this port. Let's validate to see if it's successful. So this configuration is valid. Let's click submit. If you refresh the page, we can see we've got our cluster created, and our cluster has 3 topics. These are some internal topics, but the one that we care about is this booking one. And if we go to messages, we can see our message. So this message is sent as a JSON. We can even produce a message from within Kafka UI. You will be passing a message, and you have to make sure that the message value is JSON. So you can have a look around. You can see there are some headers, and this is the value. If we now go to Postman and let's say we send another request, this has been sent again. Let's go to Kafka UI. Let's go to topics, and we can see we've got 2 messages now. So if you go inside, we open the messages, you can see the time, and we can see this is the correct payload. So the messages are getting produced, and our message producer is the booking service. We want to be able to consume these messages in another service, and this service is called order service.